Hello friends, welcome to the BI Courses YouTube channel. In this video, we will conclude our tutorial on best practices in Power Query. A quick recap of what was covered in the last tutorial. Number one, we started with the importance of checking data and its type and how it is done. Secondly, what the benefits we get upon consolidating the similar transformation steps together. And point number three, making use of step properties. Today, we will see why should we merge or append queries only if necessary, and understand why to prefer SQL statements over complex transformations. Let's start with merge queries. Merge queries in Power BI is similar to SQL join. Over here, we can make use of this button merge queries to merge two tables or queries together based on a joining key. But we must make a note that if the tables are way too big, large, or if the joining condition can result into Cartesian product of rows, that means m into n, then the resulting table could be huge. In current scenario, the database is way too small. But in term, when in enterprise, the tables could contain millions of rows, and Cartesian product can lead to billions of rows, leading to error during refreshes or during the first load itself. Hence, we must be cautious. Let's see how it is done. Here is our table dim product with product keys on the left hand side. It's unique. For example, if we select number 4, you will have just one record against it. We'll clear the filter. Now let's see fact table. In fact table, we have something known as sales key, which is unique here. And for each sales, we have a product which was sold in that particular sale item, sales row. Here you see we have different products being sold at for different sales record. What one can do, how we can demonstrate over here is we will join product table with the fact sales table, and we will try to fetch the sales key for each product in our product table. Let's start. We'll hit on merge query. This is our first table, dim product, and our fact sales table. We'll join it on product key. We'll let it estimate. It says that we have matches. We are doing the left outer join. All the rows from the product table and the matching ones from the fact table. Seems good, isn't it? Let's hit on OK. We will try to see what all columns we are interested in. As said, we are just interested in sales key. We select sales key. Now if you see, for the same product 4, we have like n number of rows, right? So this can lead to problems, errors, because this is our dim product table. It isn't supposed to hold the information from fact table. This we did deliberately just to demonstrate that how Cartesian product can possibly happen. But in real world scenarios, if we join two tables and those two tables can possibly result into Cartesian product, then we can definitely have issues. Let's now jump on to our next module. Appending queries. Let's understand what appending queries are. Appending query means stacking two or more than two tables contents of table one after another, which means that the number of columns and their type should be same so that we can append them together. Generally, we do append queries where we have similar information from two or more than two different sources, and we want to combine them together so that we can do analysis based on just one table, not 4, 5, or 10 different tables from different sources. Like here you see, we have employee information from different sources. Let's consider that these are coming from different sources. Now what we would like to do, we would like to combine employee 1 and employee 4 together. Let's see. The employee 1 contains a few rows which we see that are already existing in the employee 4 table. Still, we will go ahead and try to append because we really don't know how many are common and how many are not. What we will do, we'll hit on append queries. We will choose a table to append. So current table, already chosen table is employee 1. We are choosing employee 4. We hit on OK. And look, the two tables, employee 1 and employee 4, are appended together. Now here if you look, employee number 4 is common. It got appended. We have two records for employee number 4. We have two records for employee number 6. We have two records for employee number 7 and 18 and 54 too. And by default, Power BI is not eliminating the duplicate rows. So what can possibly happen is that after appending, if someone continues to work on, like data modeling or visualization, he or she might miss out that they have duplicates in their data, which will lead to wrong insights. Hence, we should be choosing append query very cautiously, and we must make sure to get rid of duplicates if required. Another problem with append query is that if we have way too big, volume of data, then append queries can possibly result into errors during refreshes. If we have millions and millions of rows, such scenario has happened and keeps on happening with different people working in organization or enterprise. Hence, we should avoid using append query and also the merge queries and try SQL statement. We should rely on SQL statements with all those, fancy joins and conditions. What we will gain with SQL statements, let's see next slide. Let's talk about SQL statements. SQL statement. SQL is a structured query language. It is a language which is used for querying databases. Why we are preferring to use SQL over other steps which we use like appending, merging, or any other transformations which we try to apply in Power Query is because with SQL we can trim the volume of data even before bringing it into Power BI. For example, if we have a million of rows, then before bringing those million of rows, if we really require just handful number of rows or columns, then it is very easy to choose only those columns, right? Or provide a condition right here in your SQL so that you bring only those rows into Power BI which are really required for your reporting, current reporting purposes. Secondly, when you apply a lot of steps in your Power BI, for example, when you apply steps in your Power BI, those are added over here, right? May that be renaming column, or may that be a new calculated column based on existing column, or whatever. When those steps are applied and when the refreshes happen, all those steps are applied again and again in each refreshes. Consider those steps are being applied for 50 million, 250 million, or 500 million rows. It could be 1 billion too. What will happen? It will take a lot of time, and chances are more that for some TCP error or some any other reason, it might fail. Wouldn't it be beneficial to have those transformations already done in your SQL and then bring only those rows in the format you want it to be into your Power BI, so that Power BI does not have to do that heavy lifting, which it is not really meant to do so, isn't it? You have dedicated SQL language for bringing in the data. So let's use it. And the third reason for preferring SQL statement over transformations in Power Query is that this language has been known to us since long. All of the data analysts are expected to know how to query their database. It's quite easy to debug any issues, check any issues, and do required transformations, manipulations right here on your database rather than performing something similar on Power Query. So let's take this example. Over here, if we just run this SQL statement as is without any condition, let's do that again. We have 293 rows. Now we want employees who got hired on and after year 2000, right? So over here in SQL, it's very simple. You will just use a function year, hire date greater than 2000, and this will do the trick. Just 30 rows. How about if you have done the same thing in Power Query? You would have possibly gone all the way to its hire date, right? And from the hire date, then you would be choosing date filters, something like after a date, and a date would be 2020 22, right? Sorry, 2020. So all those navigations and everything, right? And then a step would be added again. Consider that this is being applied to 500 million rows. This process will take time. It will take its own time, and also it depends upon how much wide your table is. Instead, doing it over here is quite simple and easy. Hence, we prefer to use SQL statements over transformations in Power Query. In SQL, you can easily do complex joins, transformations, and even debugging. Alright folks, thank you for watching the video. I recommend practicing best practices while transformations on Power Query and make use of SQL statements whenever you feel necessary. In next video, we will deal with data modeling in Power BI Desktop. Till then, stay tuned. Before you go, please press the subscribe button to stay up to date. See you in the next tutorial video. Thank you.